Whenever you're ready.
Okay, so during the exhibition, I decided to choose the popsicle stick project assigned by Ms. Singh around December 20th. Okay, the agenda of the project was discuss the purpose. About that. Okay, discuss the purpose of the assignment, description, explain and brainstorm ideas, able to construct a bridge out of popsicle sticks, and reflect the positive and negatives at the final results. Okay, the purpose of the project. During regular physics class, we used the science project by Ms. Singh to design a bridge that is spanned at least 14 inches in length. The challenging part of the project that you was only allowed to use 200 popsicle sticks in maximum, and not using any additional utensils. At the end, each group will have a competition to which bridge can hold 5 pounds in 1 minute. Oh, and this is basically the overall format that we've seen assigned us beginning and the end. And this was like the reflection. It was like the reflection she gave us at the end to write about. Okay, description. This is for prior knowledge of what we're going to even see in the project. During unit 3, prior to Ms. Singh introducing this project to us, we were discussing about three different Newton laws: frictional force, pulleys, and inclined planes. Okay, the correlation. This correlates what we are learning in class because we must create an object that's capable to produce a great amount of normal force and that could withstand the gravitational force. The normal force being perpendicular to the object surface and also supports the force. What is Newton's third law? Newton's third law is every force that is a reaction force that's equal in size but opposite in direction. That is to say that whenever an object pushes another object, it's getting pushed back opposite direction equally hard. So basically, like if I put something on the top of it, that's the amount of force is this equal force being pushed from the object and from the desk. Okay. This is me and my group's initial brain. These we got from images from online. This is our brainstorming ideas. My group members was Johnny and Aaron Campizano. I'm not gonna read all this. I'm saving myself. This is a lot. So the construction process. We decided to make an overall base of just one whole layer of popsicle sticks. We decided to make it 18 inches long instead of 14 inches. 14 inches was the maximum. We decided to make it 18 inches long. Then we decided to place X. We decided to place X popsicle sticks across the entire layer to try to make like a strong base for it. And then after we just continually just keep placing popsicle sticks over and over from top and bottom. We decided to we constantly put as much glue as possible, and then at the end we decided to put wood glue because we wanted to use wood glue from the beginning, but then we realized that wood glue takes like 30 minutes for it to dry, and hot glue gun takes is very quick and easy. So we decided at the end we placed a whole overall base of wood glue. Just place it all over the entire project so that it can be stronger, like a stronger base to it. Okay, and the weights that we use, Ms. Singh gave us the option, gave us multiple kinds of weights. We decided to use textbooks, the physics textbooks right there as you can see, and the weights downstairs. We only had the 10 and 8 pound weight. Each physics textbook equals 2.5 pounds. We had a black weight that weighs 10 pounds, and an 8 pound weight, and an 8 pound weight. Oh, and this is the video of the results.
I think cameras might slip it.
Okay, so we decided to do it like this. We would do it like it'd be a weaving pattern. So first we did the first row on going this way, then we're doing it this way, and in the middle, since it bended so much, we were doing X all over in the middle. wouldn't bend as much. That's basically it.
Any questions?
About the length.
Yeah.
The length
What?
of the bridge itself.
The length of the bridge is 18.
Why made it so long?
Yeah.
Because, unlike other groups, we like to be exactly what we was told to do.
That's not
It was
exactly what
14.
it
Well, rather we were told to do at least 14, so we wanted to make sure that we passed
Did it say at
14.
least?
Is that at least?
It's at least 14. So we wanted to make sure that it was at least 14. And then
So, but then this, as you can see, this minute was a minute, so we was able to complete the goal to hold our bridge up to 1 minute. This was the bridge, but unfortunately, after we completed the task, everybody wanted to do more. Like this here. I'm sorry, it broke. I was spinning.
I have seen
You spinning?
it, yes.
So, explain, like after we was able to complete the goal, we was able to complete 21 pounds just to do that, and then everybody wanted to keep adding on more. And it came to a point when Johnny tried to put 72 pounds. Yep, 72 pounds.
72 pounds.
72 pounds.
How did you achieve 72 pounds worth of weight?
I believe we added a lot of textbooks. I remember, and we grabbed some extra weights from downstairs. It was able to hold it for, I could say, about like 30 seconds. Then eventually snapped in half. I'll get into conclusion on the things we should have done. It probably wouldn't be able to hold, because as I can see, I learned a lot because some students was able to hold and sing. They were able to carry and sing for a minute. So yeah, we need major improvements. Okay, this is the applied knowledge of it. I was able to get a screenshot and play what's actually going on. I was able to put the normal force is going upwards and the gravitational force is going downwards. We learned about many types of forces. We learned about frictional force, gravitational force, tension force, normal force, magnetic force, air resistance force, continuous. Based on this bridge project, the only forces that we were able to apply was based on this bridge project, we was only able to apply the normal force and the gravitational force. The normal force is the normal. Sorry, I did not edit this. The normal force is the support force exerted upon the object that is in contact with another stable object. The bridge is exerting an upward force upon the books in order to support the weight of the books and weights. Gravitational force is a force of gravity. It's a force of gravity with which the Earth, Moon, or other massively large objects attracts with another object towards itself. Basically, the weight of the object is pushing downwards. The weight are pushing downwards due to gravity. Sorry, I did not prove this before. Okay, my lesson in conclusion from this project. If we as a group was able to restart this project, the major improvements we will do is make a stronger base and prevent it from bending. I feel like the bending is what kills us the most. Because like as I visualize other groups, some like Janet's group, like theirs was similar to us, but then it wasn't bending at the sides. It wasn't bending when you place an object in, and that's how they was able to hold up more than 100 pounds of weight. Ours eventually started bending after you just put one textbook in. Somehow it was still strong enough to carry up to like at least 30 pounds, but when you put books in it, the sides would rise up from the table, causing it to bend, and then it came to a point when our group member put too much and then it eventually snapped in half. We was able to complete the goal, but I was very disappointed. I thought we could do better. And also, I just had a theory that like adding a whole bunch of different kinds of glue would maybe put some kind of impact into it. Not like Elmo, but like other strong format glue. Because I heard like some people use cement glue, and I heard that their project did very well. So I just lack materials, and we should use what we have. That's basically it.
Why did you guys choose a 1-layer bridge? Because you had some. I saw the 1-layer bridge you had, and you had a 2-layer bridge. Why did you guys choose 1 layer as opposed to 2 layers?